Hey there, Patriots. Let's go ahead and move on to Unit 6. Now, one word of warning. Right now, it is 11:23 on the Thursday before Turkey Day. So 1 week from now, I really hope that you guys are already eating turkey dinner, as opposed to my family who likes to not get food ready until 3 in the afternoon for some reason. I don't know why. But 6 p.m. That's even worse. You got to sit there and wait for it all day long. But anyway, I know that you're going to be so highly distracted by turkey and Black Friday and video games with cousins and whatever it is that you do. I know you're going to be distracted by that. The last thing you're going to be thinking about next week is your math assignment. I get that and I accept it. That's the last thing I will be thinking about. So, what I need you guys to do, get this done as quickly as possible. In home, in class, I don't care. Get this done today or tomorrow. That way you don't have to worry about it over the break. Because what's going to happen is if you don't get it done before 4 p.m. on Friday, then you're going to forget about it until Tuesday after Thanksgiving, and then you're not going to remember what in the world we did. Get it done now, submit it. That way it's just all taken care of. Okay, that's my 1.5 minute long disclaimer. All right, let's go ahead and move on. So we're going to be dealing with inequalities. Now, inequalities are these guys right here, less than and greater than signs. Now, what we're going to be doing, honestly, is a little bit of a review from middle school because we're going to be talking about graphing inequalities on a number line, which we do quite a bit right here, which I believe you guys did quite a bit back in, I believe, 7th and 8th grade. But we're also going to be focusing on how to write inequalities from a verbal situation. The place we're going with this overall in the by the end of the unit is being able to learn how to graph. Come on, get off of there. The two variable inequalities, which don't write that, but that's going to look something like y is less than 2x minus 7. And we'll learn how to put that onto a coordinate plane. And that's where we're going to be going with this in a couple weeks. So, first off, for graphing them on a number line, single variable inequalities, the first thing you're going to do is draw the dot. And if you remember anything about that, when you draw the dot, you've got both a solid or open dot. A solid dot is a dot that is filled all the way in. An open dot is an open circle. Then you need to draw the line. And the line is going to go either left or right. And when it goes left, we're going to go that way with the arrow on the end, and right that way with the arrow on the end. Now, for an open dot, the two inequality symbols that give you an open dot are less than and greater than. Closed dots will be less than or equal to and greater than or equal to. Now, for what direction to go or to shade, what you've got to think of is that the small is less than big. I mean, there's 1,000 different ways teachers have taught you guys how to remember what direction the inequality signs go. It seems like the most common one's the alligator, which, hey, look, we even put the little alligator on that one right there for you. Alligator wants the bigger meal. Some people do this whole dot thing. Where you put one dot right there and two dots right there. And so there's the bigger number goes on the right because there's more dots on the right. Hey, lots of different ways. Whatever you need to remember which side the inequality symbol goes. By this point, you've been dealing with inequalities for almost a decade now because my daughter brought home inequality homework in first grade. So I know y'all been seeing these things for a while. You should know the bigger number goes towards the alligator's mouth. Okay, so as far as arrows going left and right, less than and equal to, arrows go left, and then greater than and equal to, the arrow goes to the right. Now, that only works, the big caveat here is if the variable is on the left. If the variable is on the right, that does not apply. It actually goes the opposite way. So let's take a look at these. N is less than or equal to -5. We are going to go to -5 and first off decide open dot or closed dot. Well, less than or equal to is a closed dot. And N is less than -5. Less than means it's going to the left, and I'll draw my arrow. For number 2, N is greater than or equal to 5. Well, open or closed? Closed. And then when N is greater than, we go right. Okay, X is greater than 1. Ask yourself, open or closed dot? Open dot. So we put an open dot around 1, and then greater than goes right. By the way, one of the ways you can look at that, if I was to draw a line in there, the arrow is actually pointing right. Whoa, that's amazing. On this one, if I draw an arrow in there, the arrow is actually pointing left. Okay. R is less than 2, open or closed? Open. And we go left. N is greater than 5, open or close? Open, and greater than goes right. 6, R is less than or equal to -2. Closed. And less than goes left. Okay, 7. K is less than or equal to -2. Open or closed?
It's the same thing as number 6, but with a different letter.
You're right. It is the same thing as number 6 with a different letter. Oops. Okay, 8. M is greater than -5. Open or closed? Open, and greater than goes right. Now, for 9 and 10, I got a problem because the variable is not on the left. The variable is on the right. So, here's what I want you to think about. If I had, in one of my equations earlier in the year, 9 equals x, isn't that the exact same thing as writing x equals 9? Now, what actually happened there is we've been drawing this line on our equal marks. What's actually happened is we're kind of reflecting over that line. And when we reflect over the line, the x and the 9 swap places, but nothing happens to the equal mark. But the reason nothing happens to the equal mark is because it's literally symmetric about that line. So, whenever I go to reflect it over, the 2 comes over here, the x comes over here, and that sign gets reflected as well. And it becomes x is greater than or equal to 2. Now, that also just makes sense because in the top one, the alligator's eating the x is bigger. In the bottom one, the alligator still has to eat the x. So we got to flip that sign over when we reverse it. So, open or close dot at 2. Close dot at 2. And then I'm going to the right. For number 10, again, we're going to flip that around. But when I do, the inequality sign reverses because we still got to open towards the -5. And now, open or closed? Closed. And which way do I go? Left. Now, remember what these graphs actually mean. Like over here on number We'll use these two as the example. Any point that is inside of that line counts as an answer to the inequality because it makes the inequality true. Like, for example, if I threw the 0, is 0 greater than negative 5? Yes. Okay? Over here, what about negative 3? Is negative 3 less than or equal to negative 2? Yes. Now, the dot is where it becomes open or closed, is where it becomes important to understand what's actually going on there. Okay, right here, if I was to do negative 4.99999, that is still true. However, if I hit 0.5 itself, is negative 5 greater than negative 5? No, that one does not work. So the open dot is saying it's everything up to it, everything approaching it, but not counting the 5 itself. On the closed dot, again, if I go in and pick another point, if I do negative 2.0001, negative 2.000001, is that less than negative 2? Well, yes it is. But if I choose the negative 2 itself, negative 2, well, let me do that in purple. Negative 2 less than or equal to negative 2, is that one true? Yes, it is because of the equal to. So that one I'm allowed to actually touch the point, okay? So realize the open dot, closed dot is the exact same thing as your less than or greater than, just in graphical format. Later on in the unit, we'll get another symbol that's also very, very similar to that. Okay. Now, we're talking about writing inequalities from verbal expressions. Okay, 4 is greater than 3 is how that is read. Now, whenever we have a greater than, we're talking about essentially the minimum value. That'll make more sense when we start doing our examples over here. This value is not included in the solution. So let's go ahead and look at words to keep track of. Greater than, more than. Exceeds is also one that you'll see. Okay. To win the game, you need more than 5 points. So, the number 5, is that a maximum or a minimum for this scenario? Well, that's giving you the minimum number you need in order to win. Okay, so to get more than 5 points, you need 6, you need 7, you need 8, or farther up. So 5 is the minimum. And I'm just going to write min. Now for these number lines, you don't necessarily have to fill in every single one of these, because honestly all that really matters is that 5. Now, is 5 included in the answer, in the solution? If you get 5 points, do you win? No, you need more than 5 points. So 5 is not included. So we open circle and then go. Okay, exceeds $80. Well, if it exceeds $80, that means it's going to be more than $80, right? So that means that the price is greater than 80. I'm going to put my 80 here. And so it's going to be greater than 80. This is also 80 is the minimum possible value it could be. But again, it can't be 80. It's got to be $80.01 or more. Okay, number 3, these word problems. We're going to evaluate them the exact same way we have before as far as rates, starting values, and totals. So, on a trip, you make $18 each hour. The $18. Rate, total, or starting value? Rate. Let me do that in purple for my rate. You make $18 each hour plus a $25 work travel reimbursement. Now, that work travel reimbursement, does that say it's going to happen every hour, every day, or is it on that one trip? It doesn't say. So on a work trip, you get $25. that implies that you're only getting it one time. That is a starting value, which I've been doing in orange. Write inequality to show how many days you have to work to make greater than 300. 300, is that a total, a rate, or a starting value? That's a total. So now when I have a rate, a starting value, and a total, that is a a slope intercept. So I'm going to do 18x plus 25, and then I've got my 300. But now the question is, what symbol goes there? It can't be equal to, because I've got this greater than. Now, always think through which one's bigger here. If I want to make greater than $300, what's bigger? The money I make or the 300? Greater than 300 means the money I make is more than 300. So, of those two, this one represents the money I make. So that one has got to be bigger. So word problems, always evaluating which one is the bigger value. Okay, so for the less than symbol, that is also a maximum. Then we also know that this one is not included. And our words that we get there is less than or fewer than. So I have less than $5. Well, is $5 a maximum or a minimum for the amount of money you can have? That's a maximum because the amount of money you have has got to be smaller than it. Okay, so that's a max. Also, we got our 5 here. If you have less than, you cannot have exactly 5. And so we're going to go that way. Open circle. Okay, there are fewer than 20 cars on the road. Once again, that's a max because the number of cars that we need is going to be smaller than that. 20 cars, open circle because it can't be exactly 20, and then less than. Okay, moving on to number 3. We want to write an inequality that expresses this sentence. Now, we covered this type of stuff back in Unit 1, and it's kind of going to come back to haunt us if you don't remember how to transition these sentences into algebraic expressions. Now, remember that we had, anytime we had sum of, product of, difference of, that always ended up being a set of parentheses with whatever operation it was, in this case, sum, being in the middle. So the sum of 3 times a number and 64. So the and is where the plus goes. So 3 times a number is going to be 3n. And 64 is going to go there. Now, we used to have just is less, or we used to just have the word is or equals. Well, now we got to focus on all this, the is less than. That's going to just be our less than symbol. And then, of course, that 62 is just going to be 62. Now, in this particular case, those parentheses ended up being unnecessary, so we can go ahead and erase those. But in other cases, they actually are necessary when there's a distribution that has to happen. Okay, last page of the notes. Greater than or equal to. When we have greater than or equal to, this value is included. Included. And our phrases, greater than or equal to, at least is one that's a little bit strange, but is in there as well. Also, no less than or no fewer than. Also realize that these are always going to be minimums. Okay, to get credit for Algebra 1 this semester, you want to make at least a 70 average. That at least tells me that it's going to be a minimum. And again, here's our 70. This one I'm going to put a closed dot on because at least means 70 counts as well. And then we're going to go up. I would actually argue that that's actually not exactly a correct statement. If you wanted to be really accurate, you'd actually say a 69.5. Because that way it'll round up, but whatever. We'll go with it as it's written. Okay, to stay healthy, the average high school student should sleep no less than 8 hours. Okay, no less than or no fewer than is also one of ours that is a less than or equal to, or greater than or equal to. That means that 8 hours is the minimum amount. There's our 8 hours. Close circle, and it goes to the right. Okay, example 3. Mary works 2 jobs and makes enough money to pay her bills. She makes $10 per hour. Well, rate, starting value, or total. That's a rate, so $10 per hour at PetSmart and $12 per hour waiting tables. 12 per hour is another rate. Write an inequality to represent how many hours she has to work at each job to make at least $280. Well, that one's going to be our total. 2 rates in a total means standard form. And also on these standard form problems, I prefer to write them in a way, or the variables that have meaning. So whenever I write 10, well, she's making $10 an hour at PetSmart, so I'm going to use a P for PetSmart, plus $12 per hour waiting tables, and so I'm going to use a T for the tables she's waiting. And by the way, if you're making $12 an hour waiting tables, then I'm guessing that that's including tips and not just wages, because wages for waiting tables is actually fairly low. I don't know what it is right now. It used to be $1.75. It might have gone up to $3. But they keep it that low because you're supposed to be making tips, which is why you should always tip your waiter, because they're not making very much money. Okay, and then our inequality sign, at least, means that, well, what's going to be bigger? The amount of money that she makes or $280? Yeah, the amount of money. So we're going to go greater than or equal to, and then $280. Okay, last section. This one is also included. And there's a small typo there. Down here where it says is no more than, the word no should be in there, is no greater than. Okay, to get credit for Algebra 1 this year, you can miss no more than 18 days of school. Well, what that means is, we put our 18 right here. 18 counts, but what other types of days are in there? 16, is 16 count? Does 20 count? Well, no more than means you can't get on the positive side of it. You've got to go this direction, which means that 18 is a minimum. Soccer team can have at most 26 players. Well, there's my 26. 26 counts. And if they have it at most, that means they can't have more than. That means they can only have less than. So it's going to go this way. Which makes that... Whoa. I wrote the wrong word on those. I'm sorry, that's max on both. I don't know. I'd like to know some excuse. I just goofed. Okay, example 3. Here's another one of these number sentence expressions. 8 less than. Now remember, in our number sentence expressions, this less than is one of our switch order phrases. Less than means minus, but it happens on the end. So it's minus 8. So it's 8 less than the product of. Now that product of is another one where I have to have parentheses. The word and is our multiplication. So I'm going to put my dot for multiplication. 3 and a number. So 3 and a number would be 3 times n. Is fewer than or equal to negative 26. Well, again, when you read is fewer than or equal to, you got to say which one's bigger, which one's smaller. Well, if this whole thing on the left is fewer than, then that's where we're going to get our less than or equal to. So just make sure that you're reading these things carefully. And just like I said earlier, please make sure you get this stuff done quicker, sooner rather than later. However, if you're actually not watching this until after Thanksgiving break and you're watching this on that Monday or Tuesday, then hey, get it done today because it's due tomorrow. Y'all have a good Turkey Day.